Hi everyone. Really happy to be here and very excited about actually people speaking a lot today about history and about the DAO hack which happened in 2016, because that was the time when I was just getting into Ethereum and I was watching all of that and I was wondering, oh my god, how do you even deal with this kind of immutable contracts and this kind of vulnerabilities you're getting. So that's actually the way how I got into the Open Zeppelin, because the Open Zeppelin mission is to protect open economy and help protocols and projects to stay on the safe side. And I started exploring and I got into this field really quickly. For those who may be less familiar with Open Zeppelin, so we're mostly famous for our open source public goods libraries, which we do as a public goods for Ethereum space, and we contribute to other ecosystems as well right now. And from there, a logical extension is to do the audits to help the projects to make sure that the implementation of those libraries is secure. And the last not least is our Defender platform, which provides operational security, and we recently introduced their ability to do code scanning from GitHub repositories to find the vulnerabilities in an automatic manner. You can do the deployments, you can do the monitoring there, a lot of stuff, transaction execution, etc. So the famous Murphy law, right? It's arguable, but it works in a space really well, or speaking mathematically, basically if there is a probability of something going wrong, well, it will go wrong on over infinite time span. And, some reasons why it goes wrong. We've seen MPC protocols being hacked, like M of N kind of patterns being vulnerable, and plenty of other things happens. And people are often saying, not your keys, not your coins, but basically it's not really your keys, it's just a number. Someone might know it, right? So this is always going to be a point of failure for any private key based cryptography. And we also aggregated for the last year some of the top blockchain hacking techniques. And we see here a lot of things happening on different levels of development. So the compilers, the protocols, smart contract infrastructure, and just smart contract bugs. So just to differentiate the difference between just a bug in a contract and vulnerability in the infrastructure of these contracts is that you might have perfectly well working two contracts, and then you combine them together and whoops, you get a pattern which is vulnerable, which we've seen, for example, in ERC 2771 combined with a multi-call recently. And as time goes on, actually, I assume we'll have more infrastructural kind of smart contract vulnerabilities happening just as industry gets more mature. One interesting notion, though, is that across all of these categories, there is a thing which we can identify as widespread vulnerability, which means that there is multiple parties affected, and this is much more serious. And it can happen pretty much anywhere for anyone who is dependent on a common dependency, right? So in Open Zeppelin, we are trying to help also on operational side to mitigate these problems and helping managing the vulnerabilities for protocols for our customers. In a nutshell, it's set up the disclosures. How do you do the proper disclosure? How do you identify and access? Set up the monitoring for protocols, and when it really hits the fans, how do you mitigate that? Quickly coordinate everyone, provide tools. And today, as you can see, this is quite messy diagram, but basically, mostly we can use pausing on when we're speaking about Solidity development or smart contract development in general. It's mostly going to be either you're going to pause your contracts or you're going to upgrade it, which upgradability is kind of very permissioned way, which we would like to go away from, right? As a community, it's not really an ethos to be too much permissioned, but when you need to upgrade fast, you cannot delegate that to DAO voting. You have to have some kind of security councils, and we see around that more likely you're going to have a security council around. And the pausing as well is really not the best case to do, but this is what really happens. And in the diagram, I want you to notion this white hat rescue and how much arrows in that diagram actually comes together in that, because we'll get to that later. As well as that there is actually like theoretically magical button which says like fix my problem. Magical button we always thrive though too. So let's see like the case. So like widespread vulnerability, how it can look like and how the mitigation look like. So say we have a common dependency which Bob, Alice, and Carlos use. Now Carlos detects some, like say, zero-day vulnerability in the ecosystem. The responsible disclosure would look for Carlos as actually to go for ecosystem or a security provider for the ecosystem and disclose that to them, because at this moment Carlos is not really the person in charge to do the patching himself. He's a user of the ecosystem. And then the ecosystem provider should, coordinate the mitigation strategy across all of the parties, coordinate the media disclosures. And this is what we did recently as well. And then there is like a game theoretic model around that basically Carlos, most likely because they're using the same dependencies, is most likely competitor to Alice and Bob. And he is also incentivized, to get some media victory, to go and post early, etc. The reason he might not do this like completely like a badass, because we are a community and nobody's gonna just talk to Carlos anymore if he does like really bad thing. But he could do something like maybe in the middle, like say he does the responsible disclosure and then he goes to the media post and makes a Twitter post. At this moment, actually, I'm sorry, but this arrow had to be here. So after he made the disclosure, he goes and makes a media post. What happens in this moment is that security provider is not more, or ecosystem is unable to have a time to provide the proper mitigation strategy for Alice and Bob, and Alice and Bob are not happy at all about that. But for Carlos, it's a media victory. Everybody is sharing his Twitter post, and even worse if he is making non-coordinated investigation, because in that moment he is actually posting like all of the on-chain data for hackers how to reproduce the attack, which is the worst you can do really. And this is why when we're thinking about this, we actually have to come to the community values. I think the community values are really important because as ecosystem, if you run your project, you are actually, you might have like grant allocations and you can actually sign up people to some kind of community code of conduct for this kind of cases. And you have quite a lot of things. You can actually like build an ecosystem-specific expert set to bring these values all together and have some specific experts to come into the work when the whole ecosystem is affected, particularly for your projects working in your field. And then, just give like a help, support as much as you can. These projects is also important. It all comes down together to something we can actually start thinking about as ecosystem emergency protocols, which are hopefully at some point automated, but right now it's actually a quite manual process of people just communicating and talking to each other about things going wrong and needing to fix quick and how. So here's a use case. So, this hack happened recently. So in a nutshell, this is what happened. Basically, you had an attacker who could call a trusted forwarder contract, which would call a multi-context, multi-call contract. And the multi-call would extract the trusted forwarder data and would execute it from, it would call it as a victim. So this is infrastructure. So the contracts are perfectly secure, but if you combine them together, you get a vulnerability. Now, in our case, first thing was, to acknowledge and assess and assure. At this point, we already had to have some public disclosure about that things is happening because it was already on media by that time. The second point was that we had to actually provide some triaging and monitoring for the projects to see if they're affected. That was a moment where our code inspector at Defender platform went on, and we added there the vulnerable pattern, and you could scan your GitHub repository, and a lot of projects did that, and it really helped a lot. And then their accidents started to happen, and at this point we had to do the proper disclosure of how to do the mitigation strategy publicly. Even though before that we tried to approach in Telegram on private basis all of the projects that we could identify. Yeah, so this is in a nutshell how like one of these cases happened internally for us and what we did there. And it wasn't really perfect. It could be better, right? So let's look into the future. How do we actually make the ecosystem more secure? Let's zoom out and think about, okay, smart contract security, how do we make it better? I really like this comparison with industry, more mature industry like automotive or air flight and airplanes. You know, it would be nice to have this kind of checklists. However, really to get this kind of checklist, what do you really need? How do you get there to have this checklist really effective as it is for the pilots? Well, you need to have a standards. Like, look, I'm a guy who actually worked a lot in traditional industry before the blockchain, so I did a lot in electronics and hardware designs, and I'm quite familiar with how the standards are there, how important they are in order to get things really reliable. So when you're driving your car, you're not thinking about that, but these are the standards, like rough approximation of what's like high-level standards set looks like for car manufacturing and automotive ecosystem. Which here is like one is just the block is like, let's say, chip design. You have like audits as well, a lot of stuff. And a lot of this stuff you can see is actually provided by non-profit organizations across the whole globe, working in the different countries or on the different industries and sectors. Which, you know, we are also having right now basically protocols defining their standards, actually doing the same. But, you know, it's really important to understand that picture and understand that scale you have to do that at. Because here is really like what's behind the one of those standards. This is a rough design, like not rough, but quite precise design of how you would do the chip attestation for being reliable for automotive industry, which could be compared to like doing attestation for smart contracts and working securely. And each of these blocks is a separate test group with a huge amount of tests inside. So it's huge, it's a lot. What do we have at this point in Ethereum? Well, I would say we have like something like this. It's much more simple. However, it's based on the same values as any industry is based. Basically, we have a community principles of how to do what is a proper way to disclose, what is a proper way to do the security. And in my opinion, this is a fundamental pillar of security and smart contracts. It defines why the Immunify is so important, why it's so successful, because you're able to run the bug bounties programs because it's more incentivized for the hackers to actually wear the white hat. And the same relates to funds recovery, where you can think about laws and regulations and a traditional like law enforcement as way of the rating system, and you could put some of that on chain. Eventually it will happen probably. And then ecosystems and the code of conduct, like what's a good and what's bad. If you agree upon that, it's much more easier to, you know, even if things go wrong, like one of the cases, say, the DAO hack, it is a community which voted on how do you treat this. And then the smart contract security, of course, not the last. is a second fundamental pillar, which we are trying to standardize and make more reliable over the time. And here in the future, we can plan for these magic buttons to disable vulnerabilities in non-permissioned way. Account abstraction is a great deal here because it's not just allows us to do the social recovery, it actually allows us to create more user-centric asset ownership models, where you can have more intrinsic security for the users, actually, if they are operating from smart wallets by default. And and then actually building secure apps and like some kind of audited infrastructure registries is something that I'm totally sure will come up in the future. And I can see some of the works happening in the field. So just to briefly explain some of those concepts. So security layers. Since we have like now the blobs and we have more ability to process the data on chain, do the more processing on chain, we actually are able to build more complicated security models on chain. We can build more logic. And if you think of one of that kind of like wrapper approaches is actually if you're running upgradable proxy, you're basically having some kind of logic state which is defined in your slots somewhere on the address, which are wrapping to your management logic, which is doing the state management. Now, no one really blocks you from doing more layers around that. And you can use different ways of layers. You can use as tokenized standards actually as mapping the token IDs to the message.signature, why not? And this approach, it would allow us to actually have more less permissioned ethos about bringing any security problems down, because imagine that each of those layers could be orthogonally managed from different entities. So you could have some intrusion prevention system which is being managed by entities that are formed as a DAO or on a decentralized principles. And if one causes, let's say, denial of service, another party can actually step in and disable him from doing that. So if you're interested in this, please approach me later, and I can show you some GitHub repos as well on that. More secure apps. This is what happens, traditionally today when you're doing like some Ethereum DApp interaction. You will have asset DApp, and you will approve the asset to be used by the DApp. Everybody knows that, but there is something missing, right? There is a reason why I left so much blank space, right? So the thing which is really missing here is the trusted entities, because you're gonna look like, is this DApp really secure? You're gonna check like, did Vitalik mention about that DApp? Who is using that DApp basically? Was it audited? And actually, good DApp maybe also will do the QIC or QIT on the user who is using the DApp. So they will refer to some kind of trusted entities, whether it be Etherscan or audits registry or something. And today it's not on chain, but well, we could put it on chain, and there are some initial thoughts on that, and there are actually EIP for doing the audits on chain, which I think is first great step towards that. So that next time when your grandma goes to Ethereum, she is able to automatically scan from the chain what is trusted and what is not, which is great, right? And user-centric solutions in age of account abstraction is how I title this. But basically, this concept is about thinking that, okay, account abstraction is not about ERC 4337 just. It's about general consensus about that, hey, like smart wallets are the way to go to store and operate your assets. Once you have this way of thinking, you are able actually to think that, wait a second, like smart wallet can be thought as operational system which protects user. Because in case where, you're working with traditional, well-established operational system and computer architecture, you don't think about that, but let's say quickly, let's imagine you have a Wi-Fi module which opens the door protects an asset. So the software which has an access to this Wi-Fi module to open the door can be mapped to saying it's owning the asset behind the door, right? So in this manner, if you're installing the app, no app is able today really to access your Wi-Fi module that easy, because there is an operational system which manages API access to the low-level resource. It will go through the OS. And if we think that we have smart wallets today, we are actually able to start thinking and designing systems where you would have more user-centric security around, particularly owning the assets by the user and then installing the apps and granting them permissions as a OS would do with the API. And this brings really a lot of benefits, because users can not just own the assets more securely, they actually can be in charge of upgrading. And in this manner, like, I really love the previous talks about the interfaces, because really, if we think about an asset, it's not an interface. ERC20 is not defining how do you store an asset. It defines an interface. How do you manage that asset? However, the storage, the way you're organizing the storage can be absolutely different. So you could interface ERC20 tokens through the asset storage which are based only to the user decisions. And then you could have upgradability, which is managed by the user, first of all, because he is owning the storage and just giving you a permission to access it through the ERC20 interface on his premises. And one of the things I really think is going to happen in the blockchain space is that, like, automated flow control is going to become much more important. Since we are getting like really closed loop economies where, like, funds are just flowing around the chain, it becomes very, very similar to what you would expect from electronic circuits, where once you ship it, you cannot really modify it. But in order to do, like, automotive industry is a great example. No one is going to let you, to qualify the chips if you don't have like basic feedback loops to regulate and read the chip state to understand that the flow is correct, and then you would apply the automatic flow control to disable and fix the issues on the fly. Do the recoverable fuses is one of the examples for that, where you could say block the transactions which are hitting over some kind of thresholds of per block or per day or per hour expected flow through that particular contract or method or liquidity container, which you could imagine. And really, this is more like, if you're interested in this topic, the theory behind that is a dynamic system theory and control theory, which is more like in traditional engineering, I guess. And then standards. There is a joke, like, it was like, there sits 10 engineers sit in a room and they say, hey, there is 10 standards. Let's make one united standard. 1 year passes, there sit 10 engineers in a room and they say, hey, there is 11 standards. Let's make one united. So I want to end up on that. Let's not try to make one united standards, but let's try to make the standards for the end user security and sovereignty as well as we can, just to make the system really secure and working well. So, expanding this idea further, have still 5 minutes. So, you could think of this kind of like trust flow where each arrow is a flow of trust from some contract. One could say store the asset, which is basically just a slot at some address and a bytes set or unset there, which is by user given access to the driver, and the driver can implement their standards, which can, in its turn, obey to the wallet, and the user wallet will dictate who is able to access that storage and that asset driver. And then you could have, as I was mentioning before, secure registries or apps registries where you could actually query, let's say, hey, I want to use a DeFi protocol and I trust, these audited companies and this kind of rating system, and get me please good route to exchange my ETH to the whatever token I need. And the same way could apply to the app implementation, app storage. The cool thing about that, basically each part of this could be encapsulated its own layers of security. And then in between of those, you could basically install circuit breakers. And whenever, let's say, you have a security provider who says hey, the app is not secure anymore, it produces a vulnerability, it could just go to the app registry and just lower its rating, bam, user is safe. And in the same manner, the user would be able to say, hey, I don't trust this registry anymore, it's too much centralized, and he could switch out. Yeah, so this is kind of a concept. So thank you for your attention. I really appreciate being here. And if you have any questions, if you want to collaborate, please reach out to the email, and thank you.